Hello everyone, welcome to the session on finite element analysis using ANSYS Workbench. This course is designed to help people across the world who are seeking the knowledge on finite element analysis using ANSYS. It can be researchers, scientists, students, or the educators who want to add value in whatever the work they do. This session mainly focuses on the geometry cleanup. In the previous session, we talked more about the SpaceClaim, which is one of an excellent module in the ANSYS for geometry creation and editing. We have seen an example of C channel fixture by moving the geometry and pulling the geometry and splitting the bodies and making some shared topologies. This session is a continuation of the previous session to give more insight about the next level of commands that help the finite element analysis engineer in making the finite element model robust. The content that we are going to cover in this session are: what exactly is the need for geometry cleanup? What different options are available in SpaceClaim for the cleanup? I also demonstrate a couple of examples which give you a fair understanding about application of the command, how to handle the critical situations while editing with the geometry which you do not have any control. In the industry where there is a need for validation of the design, finite element analysis is the key. But all the time, the geometry will not be regular like a cylinder or a pyramid or a hollow cylinder or a rectangular block. The geometry can be as complex as you can imagine. The complexity of the geometry may come from some of the functional requirement, design requirement, or the optimization requirement of a particular object or a body or a geometry. But to handle any type of the complexity, now the finite element analysis technology or the design technology also is very advanced. Our responsibility is to make use of these available options and make the finite element model robust. The complexity of the geometry generally comes especially in automotive domain or the aerospace domain where the shapes of the geometries play a very critical role. The geometry, when it comes from design department to simulation department, these kind of geometry complexities, geometry imperfections, missing of the geometries can be expected. That can be because of inadequate experience of the engineers or geometry missing at data transfer or data conversion or changing the format of the file from the native software to the neutral format. For example, if people are working in a parametric, then the default file will be .prt. When it has to be converted for the finite element analysis purpose, then it should take a format either .step or .iges. When this conversion is happening, these conversions are generally robust, but sometimes there are chances that some of the phases may miss out. We are going to mimic that particular issue and build the model by creating or repairing the geometry to mimic the exact shape of the geometry. So geometry imperfection also can come because of multiple features coming at one place like chamfer, fillet and the draft, and some of the cutout features coming at one place and merging together creating the complex corners. As you can see on the right hand side geometry, for example the car geometry. So these are going to create a challenges for the finite element analysis engineer which he has to deal with. Hence, in most of the companies, it may be where the companies who believe in the finite element analysis and who would like to invest in this particular technology before they go for the prototyping, then there will be a systematic plan of distribution of the resources. For example, if they are building a car, if a car manufacturer is there and they might be having a simulation team of, let us say, 100, in that 25 to 30% of the people will be doing just the pre-processing part, that is especially on the geometry cleanup and mesh generation, that is finite element modeling. That is required because the dedication that is required by the preparation of the mathematical model is increasing day by day because of the complexity in the geometries. We are going to see the available commands in the SpaceClaim to take care of the imperfections in the geometry. So in the first example, that is the overhead tank or the water tank, that very much familiar for us, we are going to import the geometry. We examine the geometry. We can edit the geometry or orient the views. We try to eliminate some of the fillets which may not be required for us. And we can extract the mid surface of that. We delete some of the faces and we see what best we can do or how can we play with this model to learn more about the commands. To get started with, I'll open the workbench. ANSYS workbench is now opening. We click on the static structural over here on the left hand side in the analysis systems. Press hold and pull it to the project schematic. Right click, rename this as tank. Right click on the geometry and click on import over here. Browse the geometry. Tank 3D open. Geometry is loaded here. Right click on the geometry and say here edit geometry in SpaceClaim. The SpaceClaim has opened. It is minimized over here. Click on this to maximize the SpaceClaim window. Let's examine this geometry. Right click view, front view. This is the geometry of the overhead tank. If we examine this very closely, this geometry has a certain thickness and looks like this is a shell body, which means there is a uniform wall thickness between the inside face and the outside face. The geometry can be seen on the left hand side over here. We can rename this and give it as a name as tank. Now, let us assume the requirement by the customer is understanding the deflection and the stresses induced in this overhead water tank because of the water pressure, or we can say hydrostatic pressure. In that case, it is not necessary that the geometry has to be considered as is, because we understand that since the thickness of this geometry is less, this geometry can either bend, flex, warp, compress or extend because of the water load coming into it. In that regard, we have to make use of appropriate element that captures the behavior of this model more accurately. To capture that behavior more accurately, the element that is recommended to use is the shell element. Shell element will have 3 degrees of freedom for translation and 3 degrees of freedom for the rotation. In total, there are 6 degrees of freedom, which means all the nodes have the flexibility to translate and rotate. That captures the behavior more accurately compared to the solid element. In that regard, we don't consider this geometry as is as a solid. We are going to convert this to a surface body and that surface body when meshed is going to give the shell elements. I hope you are following this particular explanation. If you are not following about it, don't worry. In future session, I am going to clarify the doubts about the solid element and the shell element when we deal specifically on the elements. In this case, the first thing that I am going to do is extract the bit surface. For that, we click on prepare. On the left side, we can see mid surface. Click on this, come near the solid body over here, click on the neck. Software has automatically identified that this is a shell body and the mid surface can be extracted by compressing the outside and the inside faces. We'll just click on done. Before that, one thing we must understand, on the left hand side under the options, the thickness has already recognized, which means this geometry everywhere has a uniform wall thickness of 5 mm. We click on done. One interesting fact, on the left hand side we have to observe in the tree that this 3D geometry tank will be now suppressed and one new component will arise. That component is mid surface. Yes, we can see that the tank 3D model has been suppressed and this has been deactivated, which means it is hidden as well as suppressed. That 3D geometry will no more be considered for the analysis. I just click on the window over here. Now we can see only the mid surface that has come. Now when we zoom it, we can see just the surface, no thickness assigned to it, but the thickness is recorded. That thickness will be shown when we go to the mechanical. We are not dealing with the mechanical in this session because the focus is to deal with the geometries, imperfections and handling those imperfections to proceed for the robust finite element modeling. Now, in this condition, let us try to induce some imperfections. Let's say this particular face is missing. First, I should come out of all the commands, escape, escape, escape. So now we can see that under the design or select is highlighted, which means no command is active. I come for prepare. Before I work on any of the command, I click on one of the face and say delete that face. Means on this entire surfaces, one of the surface got deleted. Similarly, we can come over here and delete one of the face here. If we want to build a model that is finite element model, mesh model, then closing of these openings is very critical. How can we close it? Right now, we are not in a position to create a surface over here by using the blend command. So what I do, I ask software to close these gaps for me. Let's see how the software is going to respond to that. In that case, we go for a tab that is repair. In the repair, we click on missing faces. The moment missing face is clicked, we can see there are three red zones. One is over here, another one is over here, another one is over here. What happens when I click on both? This is the zone. The moment I click on that particular zone, that surface has been patched. Means with the available boundary edges, the surface has automatically created, which is very much similar to the original geometry. Similarly, I zoom this area and click on this zone. That particular patch also will be now packed. Now, what happens if I click on this face? The entire model has been solidified, which means that it became one complete closed volume. The moment SpaceClaim recognizes any of the closed volume, it will try to make that as a solid body. Most of the times, finite element analysis engineers struggle to solidify the bodies when they get only surface bodies which are not attached to each other. The overall goal is to conduct simulation on the solid bodies, but FE engineers are not going to get solid bodies in most of the cases for which they struggle. Hence, SpaceClaim is so robust that if it recognizes a closed volume, that volume will be converted to solidify. This is the beauty of the SpaceClaim. For instance, we don't close that one, we just keep that as is in the open case. I hope this has given you the clarity of how to deal with this particular repair tab. Under that, we learnt about the missing faces. Whenever the two edges are connected but they are not merging together, then we use a command called as stitch. If there are any small gaps, we can use identify the gaps and fill those gaps. With this understanding, we'll move on to the next example. The next example is about the snapping geometries. There are two bodies which need to be snapped. Let's say the problem says like this, that we are interested in identifying what is the push force required for assembling these two bodies. Assembling in the sense, because of the push force, the snap is going to expand and slide through the flat wall and fit into the cavity. In that regard, we may not necessarily need most of these pocket features or the complex features. Those features can be closed. Geometry can be simplified so that the node count can be reduced. How do we handle that particular geometry? We are going to study now. We'll come back to the ANSYS window. We click on the static structural, press hold and move it over here. Rename that static structural, right click, rename, give the name as snap fit. Right click on the geometry and say here import geometry, click on browse. I'm going to pull the file that is snap. I'm moving it to one folder for the ease of utilization, that is snap 3D. Open. Geometry is now loaded. Right click on the geometry and edit in a SpaceClaim. Before that, I need to close this SpaceClaim, otherwise I may face the license conflict. Since the academic version is being used, it will allow to open only one window of the SpaceClaim at the time. Right click on this, edit geometry in SpaceClaim. The geometry is now imported to the SpaceClaim. We'll just rotate the model to examine how the geometry construction looks like. Since the male snap over here, because of the push and fixity at the bottom, is going to slide through this curved surface, move on to the flat surface over here and fit into this snap cavity. In that regard, we necessarily do not need these fillets. This fillets plays a very important role because the sliding has to happen over there and the smooth transition is critical. In that regard, we just click on the fillets which is not required or does not have any significance for the simulation. By pressing hold Ctrl, I am selecting the faces. These faces may not be required. These faces are selected and just press delete from the keyboard. Those faces got deleted. Similarly, on the other side, we click the faces by pressing hold Ctrl. All the faces which are not necessary or going to play any significance, those fillets will be deleted. Question must arise, why are we deleting the fillet? Fillet is going to make the geometry construction complex, because of which the mesh generation will be very confined at that particular location. In other words, the finite element analysis software has to capture all those geometries to make or build a mathematical model. Since those fillets do not have any significance, we don't want to spend time on capturing those fillets using the elements. Coming back over here, there are two cylinder cutout. Click on this cylinder cavities. By pressing hold Control, select all these faces at once itself and press delete. I'm missing one more face here. Delete. All the face got deleted. Similarly, zoom here, press hold Control, this face, all the faces of this cavity. If any edge is selected, press hold Control, click again on that, it will get deselected, and now delete from the keyboard. Faces got deleted. By selecting the faces and deleting, they are getting eliminated. Let us try for this rectangular pocket. We select this face, and this face. Similarly, this, and this. All the faces of this cavity are being selected. Now type delete from the keyboard. We get failed to remove the faces, means it is not going to work out for all the cases. Then how do we remove or fill the cavity over here? The only reason that we are filling this cavity is to make the geometry construction simple. For the snap analysis, these are not really going to matter. So we wanted to close them. Now we go for the design and there is a command called as replace over here. Click on this replace, select the faces which are not required. I am pressing hold Control so that I will be selecting all those faces that are not required. Yes, selection is now complete. Now I leave the control and just click the top face over here. It's not taking. Let me first replace this particular face. This face replaced by this face. It went down. Now directly use the delete command. First click outside, delete, escape. Click the faces. Unselect this edge. Select all the faces and directly press delete from the keyboard. That face or the pocket now got flushed to the main face. Similarly, if we try to delete a face over here, 1, 2, 3, this face, this and this. When I say here delete, it completely patched that particular cavity. If we try over here, 1, 2, 3, these faces. Similarly, cavity over here, click on delete. That also got filled. This is the beauty of the SpaceClaim, wherein the complex geometry construction now has been simplified. When we do a meshing on this geometry, it is going to give us a very regular elements and the uniform mesh. I hope this has given you a very good understanding about usage of the commands, especially the prepare and the repair in the finite element analysis software, that is ANSYS. These simplified models can be taken forward for the further analysis to understand the strength, reaction forces, strains and deformations. You can be in touch with me on my number 9481635839. This is the India number. You can be in touch with me either WhatsApp or phone call, or you can write an email to me on caewwhelp@gmail.com. If at all you also want to learn this software and looking for the geometries, then on a request I can share the geometries to you. You also can visit my channel in YouTube, that is GRS CAD CAE. Stay tuned and watch out this space. I am coming up with a series of videos to help you to solve the problem using the finite element analysis. Take care and bye bye.